Hi everyone. Well, this was this huge after party yesterday at Hever, and I suspect that some of you may be today very, well, how should I put this? Relaxed and fresh. Also, concentrated and sharp. But what's most important, craving for new knowledge about SwiftUI, right? For those of you who are in the mood today, I promise that my presentation will be as lightweight and as concise, understandable, comprehensible as it possibly may be. My name is Andrzej, and I happen to work as an iOS developer at Miquido. And today I will be your guide in the fantastic world of SwiftUI. Also, I will provide some comparison of SwiftUI versus UIKit as far as some features and sections are concerned. So, let me begin. June 2019. A calm spring evening in Krakow. Every iOS developer in this city is watching WWDC livestream without a worry in the world, not expecting anything spectacular to happen. And then, suddenly, Apple decides to drop bombshell on all of them, to basically blow their minds by introducing something that has words Swift and UI in its name. And believe me, when they do so, something game-changing is about to happen. Well, after this dramatic introduction, I will briefly explain to you what the fuss is all about and what actually SwiftUI is. Well, if I was to explain this in one sentence, I would say that this is a declarative UI framework. But what does this actually mean, declarative? Well, it pretty much means that you focus on building logic, and you don't describe the flow line by line. You focus on saying what, and you don't say explicitly how it should be done. When you Google the declarative UI framework, you'll probably encounter descriptions, metaphors like the UI is a recipe of a dish. And it's kind of true. I will provide you an example of how this looks like in SwiftWord. So, there's this code. There's this ugly old world code that we've been writing for so many years that we've almost started to like this code, right? And we don't even realize how much of a boilerplate it is. This is the imperative approach, where everything goes from top to bottom. You can see that firstly we have to construct this label, and secondly we have to apply this frustrating, cumbersome, and creating bugs line of code. Translates that Paul had a fantastic shortcut for this in his yesterday's presentation, Temic. Then we have to set text to this label, set font, and then we spend 5 lines of code on just adding this to the view hierarchy and positioning this on the center of the screen. Isn't this crazy? This isn't how it's supposed to be done. And this is the new world. Am I dreaming, or is this reality? 3 lines of code, just 3 lines of code to tell SwiftUI that we want to have layout with text that will be positioned on the center of the screen. It should have a font, system font of size 20, and the weight of both. And just 3 lines would suffice to position and to lay out this screen. Actually, this may be the whole declaration of the view controller, but you'll see about that later on. And who's also using this approach? Well, as for the mobile players, Flutter and React Native. You may not like those frameworks, you may like them. I personally like them very much, but believe me that the UI approach is one of the best things that they have to offer, actually. All right, but what does actually allow SwiftUI to do its job? Because the features, the code that we've seen isn't supposed to work on Swift 5. Well, there comes Swift 5.1 to the rescue. And a couple of features that were implemented in this edition of Swift for SwiftUI to be able to work. I will now briefly cover all of them in order for you to understand what's going on later on. Firstly, opaque return types. What are those? Let me provide an example. You declare a protocol called fruit and 2 confirmations, avocado or mango. And fruit in my basket should be some kind of fruit. But we don't tell what kind of fruit this will be. This will be determined dynamically. we can see that we can either return avocado or mango, and this should work. And all that magic is guaranteed to us by this fantastic sum keyword. Secondly, property wrappers. Well, what are those? They wrap properties. Oh, thank you, Captain Obvious, but you're not here. I'll provide an example. Here I have structure called foo, and property wrapper, absolute value, that I implemented myself. What do property wrappers do? Well, upon setting the property, they can grab the value of property, apply some logic to this, and then upon getting, they could also apply some logic and return to you the changed value. We'll see below that upon construction, when we provide a negative number, it gets automatically converted into a positive number. There's the implementation. We just have to create a structure and decorate this with a property wrapper decorator. And all of the magic happens in the wrapped value computed variable, where upon setting, the value is converted into its absolute. As simple as that. And implicit returns, this is a pretty simple feature. Finally, in Swift, we don't have to write return statement. Yeah, that's super cool. And the last part that allows SwiftUI to do its job is function builders. Well, I won't cover them in detail because I don't have much time for this. This is a very complicated feature, but I strongly encourage you to dive into this. And I can tell you that by the time that first SwiftUI beta was introduced, this didn't have a formal proposal yet. So this was like crazy. And now it's time for the ultimate battle between SwiftUI and UIKit. Basically, this will be me pretending to be live coding, and you pretending to be amazed how well I do this. The first round will be about layouting stuff. Cool. So, live coding will start. But before that, I will cover the basics. Basically, what we can see on the screen. First of all, this is a UI view controller, right? You're not mistaken. This UI view controller takes 5 lines of code. Basically, in SwiftUI, everything is a view. UI view controller is a view, but also a UI label is a view, UI text field is a view, everything is a view. Of course, corresponding components in SwiftUI, not UI label, UI text field itself. And this code allows us to render this wonderful live preview on the right-hand side. I can tell you in secret that this also works in UIKit. This can render the changes in your constraints, like a live preview, like hot reload in React Native and Flutter. And those 5 lines of code should suffice to render this preview that will react to changes in code. OK, so now I will start the live coding. I will change this text. Wait for this. Oh, this was a spoiler, I think. I don't see this on my screen, so I should look here. OK. So now I've written hello Mobiconf, and this got rendered almost immediately because this is a live preview. And now I want to introduce some other text, some subtitle text. How do I do this? Well, SwiftUI doesn't have constraints. It operates almost entirely on stacks, either vertical stacks, horizontal stacks, or Z stacks that are kind of layered stacks, layer on top of layer on top of layer, 3D stacks. So we'll wrap this text in a vertical stack. And in the newest Xcode, there are very convenient wrappers, very convenient refactor tools that actually work. I didn't expect them to work, but they actually do. And we'll wrap this in a vertical stack. Cool. We'll add a subtitle. How you doing? That's great. And we want to wrap this in a horizontal stack in order to be able to render some image next to this, actually on the left-hand side. We wrap this in a horizontal stack, and we render the image. The image component. But what now? I don't have any icons in my project because I've just created my project. Well, we'll use the wonderful new feature introduced by Apple that's called SF symbols. almost 1,500, I think, predefined icons that are either filled or not filled. They come in two variants, and this is a wonderful tool. You don't need your UX designers anymore. Oh, I'm joking, you do need, but you could live without them. So I'm just choosing to display a hand, and it rendered. Now I want to enlarge this. How do I enlarge this? Well, I must apply the large title modifier to this. Why the hell do I apply a large title modifier to an image? Because the San Francisco is a font. So we have to treat this like a font, even though this is an image. Pretty weird, right? But it works. And then I want to change the color of this. Pretty cool, maybe to blue. And voila, it renders. And now I want to show you the Z stack. What I will do is applying a gradient background in the back of this stack. And I must place this entire H stack inside the Z stack. And then I must introduce the linear gradient. As simple as that. Few lines of code created a gradient background that is stretched to fill this whole screen. Cool. Now I want to set a fixed frame on this. And I do this by applying the frame view modifier. Those properties in SwiftUI are called view modifiers. We'll see later how to create reusable view modifiers in order not to write this code over and over again if you want to reuse them. Now I will show you how to stretch this horizontally, for example. We can write code like this. Minimum width of 0 and maximum width of infinity. We can see that in our conditions, it's stretched horizontally to fill the entire screen perfectly. Now I want to apply this as a background. I want to create a card view that will contain those two labels and those in this image view. And this will have a background of color white. And also, I applied a corner radius of 20 and a padding, system padding that will be automatically calculated based on the system preferences. I will apply a top padding to the title and the bottom padding to the subtitle. Cool. You can see that we have, oh, I think it's looped. And this round, I think that is a draw. Why? Because those two approaches are completely different. It's very hard to compare them because once UIKit is an imperative approach and SwiftUI is a declarative approach, those are two completely different words. As I've said, difficult to compare, but SwiftUI is far better for simple layouts and prototyping. It's so good for prototyping that I've heard that even UX designers are using this to quickly design screens instead of using Sketch. This is wonderful. Also, the benefit is that all the tedious code from UIKit is simplified a great deal. Cool. Now I will show you the simplification of code just to picture this. This code contains all you need to implement in order to have a UI table view. Here is the data source. The data source would be like 100,000 fake names that are actually UIDs. And this is the UI table view. This is almost everything that you need to write in order to render a UI table view based on your data source. And this is self-for-row at index path. And this is all the boilerplate that you need to write in order to have a working list component. Pretty crazy, right? And the great benefit, no more broken constraints. No more tedious debugging of broken constraints. Hooray! But also, I find SwiftUI hard to master, especially for those people who haven't used declarative approach yet, who haven't implemented code in React Native or Flutter. This could take quite some time to learn, to master. The second round will be about reusability, composability, and scalability. Cool. Let me proceed to the live coding. And now, I want to extract this view, because we see that we have such a mess in this code, right? We want to extract this to be more reusable amongst other views. So we just take advantage of the cool extract subview refactor feature that actually works, as I've mentioned before. And this will be a hand image. This will be a title view. And this will be a subtitle view. Cool. This looks nice, but we could do better, honestly. We could extract this whole H stack to be, for example, a content card. And we'll do this right now. We're extracting this to the content card. Pretty neat, pretty tidy and clean. And also, as I've said later, we don't want to be forced to write this tedious frame min with 0, max with infinity every time we want to stretch something horizontally. So we'll extract this view modifier just for this to be reusable. We do this by creating a struct that will extend view modifier. And here it is. The only required function in this view modifier is this body content function. And we can see that we apply this tedious code on this content. And then we can apply this modifier right there. Pretty crazy, right? But we could do better than this. We could write an extension. So why don't we do this? An extension to the view. It should return some view, as expected. And inside of this, we'll apply this modifier to fill this horizontally. And we'll use this in our code. Pretty cool. I think it's looped. So the verdict here is SwiftUI. Why? Because it promotes small views. And that's cool. Because in UIKit, sometimes we tended to have such a mess that it was very hard to maintain. And in SwiftUI, this problem should not exist, provided you care about creating small views. Also, as we've seen in my example, extracting modifiers is super easy. And SwiftUI relies on composition instead of inheritance. Also, I didn't mention this, but SwiftUI has div-based redraws. Everything gets redrawn based on the differences in the layouts, and only the changed parts of the UI gets redrawn. The next round will be about lifecycle, and this will be a short round. So you can see that we have here 3 closures: on appear, on disappear, and on receive. Basically, on appear, on disappear are 2 lifecycle events that you care about. No more view did load, no more view did appear, no more view will resign active, or so or so. And the third line, on receive, well, I didn't mention this, but SwiftUI has great integration with Apple's new framework Combine. And we can declare that this view will receive combine event. And in our case, this will be a system event that the user is taking a screenshot in his or her phone, and we provide some action on taking a screenshot. I see that I can type. OK. We can also react to user-defined events, to our own events instead of system events. Cool. So there's also other variant of reacting to appearance of the view. We could just pass the function into the onAppear, and this would also work. We don't have to implement disclosure, but we could pass just a function. Here. In this round, I think that SwiftUI has won. Why? Because it has very readable closures, and I remember times when we were arguing where to put lifecycle events in our UIKit code. And in SwiftUI, this problem doesn't exist, because everything is declared as readable closures, and you know where to look for them, you know where to search for them. They are aggregated in the views declaration. The next round will be about user events. We can see tapping on the screen, right? OK. So we want to apply some gesture recognition for the content card upon tapping on this. And how do we do this? Well, we just implement the closure on tap gesture. This is all we need to react to tapping on this content card. We could also implement some other type of gesture, on long press gesture. It also works. We can see that it's aggregated in the same manner as the lifecycle events. They are tied strictly to the screen, to the view that we want this to be applied to. and there are the actions that we need to perform. Also, we can combine gestures. We can create a drag gesture that is also a view, because everything in SwiftUI is a view, and we can combine this with long press gesture, for example. And we can react to changes in the drag gesture, but it should be long press at the same time. Honestly, I don't know how to trigger this gesture using my fingers, but I just came up with this example. And we have to assign this gesture to the image, and this also works. And the verdict here is SwiftUI. I will repeat myself. Those are readable closures, and you know where to look them, and no more remembering the whole strange classes like UI tap gesture recognizers, long tap gestures, UI motion event, touches did begin, touches did end, etc., etc. So this round is won by SwiftUI. The next round will be about state. I didn't tell you, but all the changes that are done in layout in SwiftUI are triggered by state changes, because layout in SwiftUI, view in SwiftUI, is a function of state, not a stream of events like in the UIKit. So the only way we can change layout state is to react to state changes. I will show you what I mean by implementing some state changes in my code. I have this hand image, and I want to hide this. How do I hide this using this declarative approach? There's no top bottom flow, right? Well, I declared the state property is hand image visible. And you can see the property wrapper here at state. And the property wrapper ensures, well, first things first, this is the structure. So every time the view gets redrawn, it gets destroyed and it gets recreated. But the add state guarantees that this property doesn't get destroyed upon the recreation. This puts this property inside of special place in the memory. So it stays and it outlives the whole structure. And to be able to hide this hand image and to show this, we need to add something to our body declaration. And we do this by applying an if. So we can see that this is a conditional rendering. And SwiftUI is full of such cases, and you should take this code for granted because you will see this very oftenly. And now we will see if this actually works. Here we'll change this property, we'll toggle this, and this works. Without an animation yet, but it's yet to be implemented. And now we want to change the hand image color. How do we do this? I mean, the color of the hand image is enclosed in the hand image itself, not in this content card. But how do we pass the state to the hand image, to the child of this content card? We'll see about this in a moment. First, we have to declare the state. The state of this color, let's say this is blue. And now what? Now we will change this to yellow upon tapping, just to test this. And we have to declare a binding here. Not a state anymore, a binding. A state will be passed as a binding to the child view. And this will be done using this crazy new syntax with $. It actually could be treated like a reference to a property wrapper. I don't know how to explain this to you better, but this gets passed to the binding, and the hand image reacts to the color changes. And we'll see if this works. Marvelous. The color was changed. So, as for this round, I can't compare this. Why? Because UIKit doesn't have such tools as state. It doesn't operate on concept of state. This is a new thing in SwiftUI. You can't really seek for this in UIKit. In UIKit, there was a matter of implementation, and SwiftUI kind of enforces on us this approach, this reacting on state changes. And in SwiftUI, the state management is very concise and very readable. We could see that this conditional rendering is actually pretty cool, provided you take care about small views. There are some great tools to manage the state, not only the add state and add binding that I've shown, but also add environment. What is add environment? Well, this could be used as a dependency injection to inject objects from parent to the child, but in this case, we inject a system key path, horizontal size class, to a property. And this code will actually react to the size class changed. If the horizontal size class changes to regular, this image gets redrawn. Otherwise, UI label, blah, blah, size class must be regular, gets rendered on the screen. The great benefit of this is that everything happens automatically. But that could also be a pain in the arse while debugging, right? Because some crazy bugs might arise from this. And the sixth round will be about animations. Everyone loves animations, right? So do I. And SwiftUI makes this super easy. Cool. Right now, I'm showing and hiding this hand image without an animation. And I want to apply some. How do I do this? Well, I must declare, again declare, because this is a declarative framework. I must declare that I want to show this and hide this with a predefined transition, the scale transition. And this is not enough. This is not enough. We have to tell that this state change must be connected with some animation. And when we declare this, that this will be that will be connected with some animation, this SwiftUI is searching what animation could this behavior trigger. It searches for the transition and it applies this transition scale to this image view. We'll see if this works. Here. Yeah, the layout adjusts automatically. Perfect. So now we want to do something more. We want to combine two transitions, or even three. How do we do this? Well, this is any transition API. We can see that we combined scale with move and slide. Three predefined transitions in SwiftUI. The move will be from the leading edge. And we see how this looks like in a moment. Pretty cool, right? So those are basic animations in SwiftUI. And in this round, I think that the UIKit wins. Why? Because in my opinion, imperative animations are more readable. It kind of reads better when you have behaviors line by line saying what should happen and why it should happen. And in SwiftUI, I kind of have a feeling that everything is floating around, seemingly not connected to each other. Also in UIKit, we had some great tools that we love, that we've been using for years, like core animation, for example, and its APIs. And as I've said before, for me, SwiftUI, those animations are a little bit magical, right? Those look like magic. And the seventh round will be about navigation. Navigation, we implemented the second view. It doesn't matter what the content of the second view is. We just want to present this inside of a UI navigation controller. And how do we do this? Well, firstly, we get rid of this content card, and we implement this navigation link. What is navigation link? Well, this is a SwiftUI component that has that automatically puts this second view onto the navigation stack. So we can see that navigation in SwiftUI is very tightly coupled to the view. It almost resides in the view. It resides in the component itself. And we enlarge the font. But why is this grayed out? It should work, right? No, it shouldn't, because we don't have our UI navigation controller yet. So we'll implement a navigation controller for this screen, and then it automatically turns to blue. We do this by wrapping all of this inside of a navigation view, and we don't have a refactor shortcut for this. Why is that? I'm wondering. Cool, it's blue now. You can also see that there's this green view, and this is because of the line 25 when we set the navigation bar title greeting view. But you can notice that this property, this modifier, is applied on the root child of the navigation view, not on the navigation view itself. And it makes sense because this has to be decided by the child, not by the parent. We'll change this title because we don't like this large title. And in order for this to be inline, we have to provide some displayed mode. And this is crazy. Why did they assume that that we want by default the large titles? I don't know, but this is crazy. And now we can see this works. The second step would be to present the second view modally and prepare for a little bit of magic here. Presenting modally is connected to state changes. We should write a state property here, show second view. And this already looks bad, right? It will be worse. We implement this button that triggers the toggling of this property, of the state property. And how do we show this second view, second screen modally? Well, we have to apply this sheet modifier on the root view. And the isPresented is passed. There is this state property passed to the isPresented parameter and the content to be presented modally. There's a huge ritual for just presenting this screen modally. We have to do like 10 squats, perform a rain dance, and clap 2 times, and then it presents. It shouldn't be like that. It should be far more easier than that. We see that this actually works, but the amount of code that we had to write to perform this is just crazy. All right, and again, I prefer UIKit as far as animations are concerned. Why? Because it has patterns that we love and that we respect. Patterns like coordinator, navigator, flow controllers. We are all taking those patterns for granted, and we're using this in our projects pretty extensively. And in SwiftUI, navigation is very tightly coupled to the view, I have a feeling. All right. The next question is, can SwiftUI and UIKit live together? Because so far, we've only seen them battling with each other. And can they live together? I'll say, hell yes, they can. I'll show this in an example, actually 2 examples, because I will show SwiftUI integration inside of UIKit and the other way around. First of all, SwiftUI inside of UIKit. We can see the SwiftUI screen implemented in SwiftUI. And all we need to do to present this in UIKit is to wrap this inside of a UI hosting controller. And this works. The other way around, UIKit used in SwiftUI, we just have to conform to a UI view representable or UI view controller representable. And the minimalistic approach here is to implement this make UI view function to return this UIKit view. And this works in SwiftUI as well. Actually, this is a pretty common scenario because SwiftUI is lacking some views. Actually many views, and you often have to resort to converting from UIKit to SwiftUI. And now, things that I like about SwiftUI. It's really, really fun to work with. I've spent almost 2 months experimenting with this, and I'd say that every time I had to come back to UIKit, I felt like something is wrong here. I felt like this is such a disgusting relic of the past. Once you adjust to SwiftUI, once you start using this, once you start experimenting with this, you really start to like this because it is very, very likable. Also, it is great in composable small components. It kind of enforces on you this extracting to small components. And it's 100% Swift. How great is that? Also, it is multi-platform. It can be used in either watchOS and macOS apps, apart from the iOS apps. And it's great for prototyping. As I've said earlier, the designers are actually using this to prototype their UIs, sometimes even instead of resorting to using Sketch. And things that I don't quite like about SwiftUI. Well, sometimes it has very long build times, and the previews not always work 100% well. And you may have seen that errors are out of this world. Sometimes they are completely unreadable, and they are not telling the exact source of an error. And what is striking me the most is that some parts of documentation are still missing. You often encounter missing communication while trying to implement something, and then you have to only guess how to use this, right? But what's happening? We've got a breaking news. 3 of those things seem to have been resolved in the newest installment of Xcode, beta 11.2. Yeah, I haven't tested this yet, but I've read on Twitter that those two problems have been fully resolved. So the only thing that is left is the missing documentation here. The question, do I like SwiftUI? Yes, I like this a lot. This is a fantastic framework. This is very fun to work with. And should you learn this instead of UIKit? This is the question that I often hear from the beginning, the developers that are beginning their journey with iOS. No, you shouldn't, because apps implemented in UIKit will be there for at least a couple of years, and this won't change. Even while using SwiftUI, you still have to use UIKit to some extent while converting UIKit views to SwiftUI. And is SwiftUI production ready? In my opinion, yes, it is. I would definitely post an app to the App Store implemented using SwiftUI. Well, this is quite an immature framework and young, but still I think this is ready. It may surprise you sometimes, but it looks pretty stably in the newest installment of Xcode. And the point of my presentation is that I encourage you to at least start experimenting with this SwiftUI, because you'll meet this in some point of your journey in the iOS development world. And I think that this will be used in the future because it is the future of iOS development. And I really hope that in 2 or 3 years from now, this will be used in iOS apps pretty extensively. And now I give you like 7 seconds to make a photo of this. 1, 2, 3, 4, 5, 6, 7. And 5 seconds to make a photo of this finished project from this presentation. 1, 2, 3, 4, 5. And for those of you who haven't fallen asleep during my presentation, now it's time to wake up, because we've reached the end, and thank you, and it's time for questions.